Cytrobyte. We're a group of students passionate about computer science and robotics. This year, we decided to use our knowledge of programming to a real-world application. We planned, designed, built, troubleshooted, and programmed an underwater ROV.
Our team is comprised of 3 people. We're an international group. One of our members is from China, one is from Mexico, and I'm from France.
With the junior year begin, I found a few new members that were interested in participating in the competition, and we formed a new group to participate in the MATE ROV competition.
ROV stands for Remotely Operated Vehicle. In our case, it was underwater. These types of vehicles are usually used for subsea exploration, for example, the oil spill. Initially, we started out as a school club, but unfortunately, due to some miscommunication and misorganization on both ends, we ended up losing a potential sponsor worth $1,000.
As a group, we decided it would be best if we were not part of the current Stratford Robotics Club, so we went off and formed our own group.
We chose MATE mainly because it allows us to freely express our creativity and skills.
One of our members had done it the previous year, and we felt like it had less constraints in terms of physical requirements as other competitions such as FIRST.
These small restrictions allow you to think outside the box for solutions that you wouldn't have thought otherwise. Having more power to do whatever you want gives you more creativity and just makes the whole thing more fun. The total cost of the ROV was around $4,000.
We got this money from generous donations from our sponsors. Our biggest sponsor is IntechC, which is part of the Wardy Parsons group. They donated $3,000 to our project.
Axis Communications provided us with the cameras we used to see what was going on underwater.
A few other sponsors include Sifco Machining and Dynamic Machining, which machined our parts that include the main housing and acrylic dome.
I think it's really cool how a huge company like IntechC can reach out to a small group like us and help us out in a project that is really just amazing.
Our objective during the competition was to survey a simulated World War II wreckage.
Some things include measuring the length of the wreckage, determining the orientation of the wreckage, and finding debris of the wreckage.
We had to extract some simulated oil from the wreckage using a pump. We also had to pick up several objects from the wreckage using an arm.
The ROV contains many parts that give it different functions. These include a metal detector that allows the ROV to detect metal debris in the water.
We used a common metal detector that we kind of scrapped up and changed shape in order to detect whether or not there were metal samples or non-metallic samples on the seafloor.
Another part is the tape measure, which allows the ROV to measure the length of the shipwreck.
We also had a 3D compass inside the ROV in order to measure the orientation of the shipwreckage. This compass would send in the degree angle back to a control system.
We had a mechanical arm with a claw on it so that we could grasp objects on the seafloor.
Additionally, in order to extract the simulated oil, we decided to use a pump. First, we tried a windshield washer pump, but that didn't work out very well, so we ended up going with a computer pump instead. Since both the arm and the pump were mounted in the front of the ROV, we had to devise a way in order to get them out of the way.
We used simple servos in order to make the arm and the pump lever work.
Finally, our biggest component is the HD camera, which allows us to view the underwater environment and direct where the ROV is going.
One of the most difficult parts of this project was the control system, which basically brings everything together into one. There were 2 parts of code. One of them was the computer code. We programmed the control system using C#, and basically what it does is it takes the data sent in from our microcontroller, the Arduino, and it decodes those packets into information that we can read. It also had a window so we could see what the camera was seeing.
The second part of the code is the Arduino code. It is similar to Java and C-style code. The code basically grabs the data that's sent to it from the PC and directs it to different parts of the system, which include the servos that control the arm, and the pump, and the motor controllers, which controls the thrusters.
This control system takes the input from a joystick, which is a normal gaming joystick that we usually use for flight simulations, and the software takes this input and translates it into data that the Arduino can understand.
We use the UDP network protocol between the Landside PC software and the Arduino microcontroller. This protocol basically structures the data into different packets and sends it over an Ethernet cable. Initially, in our planning stages, we plotted out a time chart on Google Docs.
We created a timeline of specific key events that needed to be done by a deadline. These events include, for example, ordering certain parts or waterproofing or starting the testing phase of the ROV.
Beginning, we had to tie bricks to the central hull to test just the waterproofing of the hull itself.
Building the ROV was really fun. I mean, it definitely takes a long time, but just seeing all your pieces and components come together as a whole is a really cool experience.
Safety was incredibly important. We made sure at every step of the way that we were doing everything properly and not doing anything that could harm ourselves.
The actual build took around 3 months leading up to the competition.
A lot of things went badly. To start with, during the testing phases, we had a lot of problems throughout the entire process with waterproofing because several connectors that were bought and deemed to be military grade waterproof were actually not at all. They kept leaking constantly and there was really nothing to fix that.
Another problem we encountered was integration between different components of the ROV. The compass, for example, worked perfectly outside of the ROV, but once we put it on, there was interference inside the aluminum housing, which caused the compass to misread the information.
Our last problem was fogging in the lens. We had an acrylic dome covering our central container, and inside of it we also had a camera, thanks to Axis, which we applied solution to both of these things in order to not have any fog when we saw it through the computer.
Financially, we were short of money toward the end because of the mess-ups that we had in the beginning, so we had to buy several parts repeatedly due to failure through inadequate waterproofing.
Time management also played a huge role in this project. We were all busy with schoolwork and college preparation, so we really had to focus during our meetings and get straight to the point.
It was really hard, especially junior year. We all had really tough classes and orchestra and tennis, and it was tough to manage time. We prioritized what we thought was important relative to our homework schedules and extracurriculars, and we ended up working quite a lot of time regardless of other constraints. So I think we managed our time pretty well.
Even though we had a lot of problems with the ROV, we learned a lot from these problems and really grew as a team as we tried to figure out different solutions.
Before this year, I had never participated in any sort of robotic competition. Being able to build a robot and a team has opened my eyes to what a real-world engineering environment would be like.
My computer skills never really left the screen, but with this project I was able to expand to other applications such as an underwater ROV. It's really nice to see your creation come to life outside the computer screen.
I always knew that I wanted to be an engineer, but I never had the true experience of what a real application of an engineer is.
Thanks to our sponsors, my eyes have been opened to a whole new world because now I kind of want to go into an engineering field.
I mean, we're just 3 high school kids and we were able to have this amazing opportunity to build an underwater robot with little assistance or interference by a teacher. Like, with this project, there was no one telling us, hey, you're doing that wrong, or hey, you should read the book, or instructions even. I mean, everything was from scratch. We didn't get any parts. So with this project, we were really able to get the feel of what a real engineer would go through.
This project gave me a true insight into what it takes to be a successful engineer in the real world. It showed me different things such as the planning that it takes and the management that it takes to be an engineer.
This was probably the best experience of my junior year and probably high school, and I'm just very grateful that we were able to participate in it.
Even though we remain a small team, we have accomplished as much as any of the larger teams. This shows that with dedication and perseverance, anyone can succeed.